Hello and welcome to the latest episode of Material Matters with Grant Gibson. The show has been running for 6 years now. However, for listeners who might be new to all this, the idea is that I speak to a designer, maker, artist or architect about a material or technique with which they're intrinsically linked and discover how it changed their lives and careers. Today is a little bit different because rather than exploring a single material, we're looking at manufacturing, how we make, move and consume the materials we extract, grow or create. And I couldn't think of anybody better to do that with than Tim Minshall. Tim is the inaugural Dr. C. Taylor Professor of Innovation at the University of Cambridge, the head of the Engineering Department's Institute for Manufacturing and a Fellow of Churchill College. He also has a new book out. Your Life is Manufactured, How We Make Things, Why It Matters and How We Could Do It Better does exactly what it says on the front cover. It kind of works as a primer for our extremely complicated global manufacturing system. Tim, thank you very much for doing this. How are you?
I'm very well, thanks, Grant. And thank you for inviting me along. It's a real pleasure to be here.
Oh, that's a complete joy. Was that intro okay? Did I get all your qualifications correct?
Smack on, yes.
Oh, good. I'm glad. I'm feeling kind of really underqualified.
Well, if it makes you feel any better, when I got this job, my colleagues who are quite mischievous put a little sign on my door. It was a little graph, 2 axes. On the horizontal axis, it said length of job title. And on the vertical axis, it had grip on reality. And they drew a nice little curve showing where they thought I was.
Well, okay, that's good to know. I have obviously a very firm grip on reality in that case.
There we go.
Good. Let's talk about your book to start with, which, as I say, is really this intriguing, fascinating look at how, why, and where we make things. It starts in a school with you attempting to explain to 69-year-olds how we manufacture. I mean, they don't seem all that interested, or they want to destroy all the stuff that you bought in, seemingly, which is, I guess understandable. But I'm just wondering, have we created a generation that doesn't understand how and where we make things?
I wouldn't want to go quite as far as saying there's a whole generation who don't get it. And there's also something very interesting I find about different nations' approaches to this. So I've just cycled here from a meeting with a Japanese colleague, and he was describing, and I lived in Japan for a little while, the situation in different countries is very different. Other nationalities and cultures seem to perhaps have retained a greater connection with the making of things, and Japan is one example of that. What I find a bit odd about the UK is we clearly have had it in the past. Well, every nation had it to an extent that you had to make stuff to eat and clothe yourself and shelter yourself. And then we had the Industrial Revolution, and it was there, and it was, largely driven by several countries, one of which was Britain. So it's been there. I think to your point, it does seem a bit odd that we've lost touch with it, though, in the UK. Not exclusively, but I think I found it most shocking, my own experience and how little I knew about manufacturing until relatively recently. I probably shouldn't admit that on air. But even maybe a better example is COVID. And just that extraordinary moment of growing up and living most of my life in a wealthy country, to walk into a shop and see empty shelves. I don't know if you felt the same, but it was a visceral shock to go, oh, the things we need are now not arriving. And you could say, well, yeah, that was just a surge in demand because of COVID and the lockdown, and it was a temporary blip. And we did recover very quickly from that. But it was the way people started talking about it, going, why are the shelves empty? Why, if we can't get it from somewhere else, why can't we just make it? And I just found that conversation seemed to be surprising when we said, well, we can't just make it because significant proportion of our manufactured goods are made very far away from the UK. And this seemed to be a bit of a surprise in some ways. People knew it, but hadn't really, it sounds a bit pretentious, they hadn't internalized what that really means.
Well, I'm interested in that. I'm guessing it isn't a coincidence that this book was published around the 5th anniversary of the COVID outbreak in the UK. Or was it?
It was an unhappy coincidence. Yes, it was very much written. There's a selfish agenda to this book, which was the institute I work at in Cambridge is a very hands-on collaborative place where we bring amazing students and visitors and researchers to work with us. And we spend a lot of time going into manufacturing firms in groups, in teams, and people come to us. It's a very collaborative, physical way of learning about things, which is really important to us. You've got to hear it, see it, do it, all of these things. And then March 20th, 2020, or I think that was the right date, we had to lock the doors on the building. And we go, well, how do we help 200 students a year learn about the real world of manufacturing if we're all stuck in our bedrooms like this? And so part of it was saying, well, is there a way I can capture the essence of what we do? I suppose just as part of an outreach exercise to say, can I explain what's going on? So if someone does contact me, I've got something I can say rather than just going, well, I'll take you to see it. Could I write it down? I had to go and learn how to do that, which was a non-trivial exercise. And luckily I had a brilliant writing coach, Anna Porshaisky, who helped me enormously.
Who's written her own book about craft, I seem to recall.
She has, yes. Handmade, an excellent book.
It's very good, yeah.
It's fantastic. It was reading that book that was also part of the story. I thought, wow, so there's a material scientist who understands the science of materials in depth. She's got a PhD in material science and a degree in material science, was saying in this beautiful way, well, but how do you make the thing? How do you make you remember it's the glass blowing she does?
Yes.
She said, well, I've used test tubes and bent bits of glass on it in a lab, but how do you make that? How do you sculpt something? How do you manipulate metal to form an object? I thought that was brilliant. And it triggered me to say, well, yeah, but what happens when you want to make lots of those? You sort of so it broke it down into there's a whole bit about the making. There's a whole bit about the moving, which was particularly problematic during COVID. But then as sort of, spoiler alert, jumping to the end of it, there's a big chunk of it, which is about us and our role as consumers. We sort of regard manufacturing, or with the language we use, is it's this other thing. It sits over there and we've got our lives. And then there's a thing called industry. And, that's over there. And it seems so clear that, and it's becoming even clearer, that we are an integral part of this whole manufacturing world. It's not a separate thing, but we've somehow come to regard it as separate. Does that make sense?
Yeah, it does. But also during the pandemic, it emerges that you worked with a hospital. You treated a hospital as though it was a factory.
A bunch of us did. I was just a minor player in that one. But it was interesting. I mean, I have such admiration, as I think almost everyone does, for the quality of people who work in the NHS and dealing with that situation. I don't know how it was done, but it was a massive credit to the quality of those who work in the NHS. But the particular thing we ended up doing was there was a whole load of operational challenges facing all hospitals. Suddenly it's like the loo roll problem. Suddenly loads of people want loo roll, it disappears. And you go, right, well, the opposite problem in the hospitals was suddenly there's far too many patients turning up. And what do you do with them all at once? How do you triage when they've got no ability to do rapid testing? And you've got people who've, need immediate care, people who might or might not have COVID, people who don't quite need immediate care, but they still need to get to the hospital for something else. It's just such a logistics nightmare going on there. And so it was some really smart colleagues just put two and two together, and we had some connections in our local hospital. And so we just said, look, we're not going to interfere with anything here. Who are we to know what goes on in a hospital? But we just said, if you've got some operational challenges, we're very happy to have a chat about, how we might think about smoothing out some of those massive spikes that are appearing. And so we were very lucky. Some of our overseas students had stayed on. They couldn't go home and they volunteered to help out. And that started some activities off. And we just looked at it as if it were a factory and said, look, this is I don't want to be too blunt about it. It's not a production line. Clearly a hospital is a much, much more sophisticated environment. But there is something about, there are inputs and there are outputs and there are processes, and you want it to run smoothly. And you need to plan for smooth operation, and you need to know when things are starting to go wrong, and are they going to get much worse quickly? This idea of, bands of tolerance of what's normal.
Well, it was running out of oxygen was an issue, right?
Absolutely. And that was one of the most compelling examples. So all those little taps that sit by most hospital beds for oxygen, it is not assumed that all of them will be switched on at the same time. I mean, it's a never happen event. Why would you do that? But as we looked at some of the work my colleagues did was around modeling. Well, if this many patients arrive, what will be needed? And if you looked at the worst case scenario, it was pretty horrific. You'd need lots and lots of oxygen pretty much on every bed, and you'd need to have, way more intensive care unit capability than existed. So a very basic thing was, well, let's deal with one problem at a time. Is there enough oxygen? And one of the answers that came back was, well, we're not sure. We've never had this system running at full power with everything being used. And so just bringing in some simpling sensor technologies and modeling approaches, you could get a picture of what oxygen was actually or was likely to be available in an untestable condition. And that just gave the wonderful clinical staff and the estates management staff a sense of confidence. They knew the top and bottom level. They said, okay, well, as long as it doesn't get too high up there and it goes down here, we're okay. It gave them just a bit more confidence.
Yeah. Interesting. Okay, so the book is being published to mark the 5th anniversary of the pandemic, or at least it's happened to be published at that time.
Yeah.
I mean, what you have missed, because it's happening right now, is the tariffs that are being imposed or threatened to be imposed by the US.
Yeah.
How is that, in your view, going to affect the global manufacturing network?
So thank you for wording it that way. Others who've asked me to talk about this have started off saying, so Tim, do you fundamentally agree with what Trump is saying? And I've felt the need to expand on that slightly and say, I'm not going to make any political or ideological comments here, but there is something fundamental about the ability to make things in your own country, make some things in your own country is pretty important. And maybe we'll come back to that later with a situation with Ukraine and defense and all sorts of other issues that in an ideal world we'd rather not talk about, but they are part of very much of our lives now. So yeah, the tariffs thing is interesting because it does distort behavior. And there's reasons for doing it. And, economists much smarter than me can talk about how this can be used in very nuanced ways to nudge things in certain directions and to encourage the development of a local. If you're a country, well, perhaps low to middle income, and you're trying to develop your manufacturing, you might want to encourage local manufacturing. So you put tariffs on things coming in to encourage local manufacturers to do more. It's a known thing. It's quite understandable. It's quite a blunt tool, though, and it has consequences. And this issue that we always try and describe manufacturing as a complex system. Not that it's complicated, as in it's got lots of things going on. It's complex. These things are interconnected, and you do something in one place and you don't really know what's going to happen far away. And so you can see that happening now as there's a whole tit for tat tariff thing going on. We can't quite see where that's going to go, but it's a pretty blunt tool, I think is what I'm saying. Well, it's a combination. It's a blunt tool that has unintended consequences. If you can have those things together.
Yesterday, the Guardian columnist and environmental activist George Monbiot confessed that he started hoarding food in case there's a collapse in the global food chain. Should we be taking him seriously in your view? I mean, do you have a cupboard full of tinned tomatoes as we speak in your kitchen?
What a great question. So I'm going to separate out there issues of global meltdown with good citizenship and being prepared.
Fair enough.
I think if we go for the latter, then yes, I do keep tomatoes and baked beans and pasta in a cupboard just in case. I don't think we're close to anything that requires panic buying or anything like that. We've seen what that looks like, and that's what we saw 5 years ago. And that's very clear. When something dramatic and clear and, you will stay at home, the shops will be shut, all of this stuff, that's a very, very different situation. Personally, I don't see us heading towards that in the near future now. And so I think there's a number of issues there. Issues of global food security, though, is huge. So energy security, food security, massive, massive topics that all sit when you're a hammer, you treat everything like a nail. But there is something about this all seems to be a manufacturing problem to me. The way in which we have designed our energy systems and the way we run them, the way we've installed them is based on all sorts of geopolitical and economic issues. Food is, all the great work that's been done by, Henry Dimbleby, looking in his wonderful book, Ravenous, and all the work he did with the previous government on food strategy. You go, the system isn't working anymore. And looking at the fact that if you take manufacturing to be field to fork, what's happening in the fields needs quite a lot of attention, and we can't go on perhaps in the way we are for much longer because there's an issue of, soil degradation and all those issues. But there's also the economics that come into play, the way we produce enough food. I mean, there's enough food produced in the world for at least 10 billion people. And estimates go up to say there's probably enough for 12 billion, depending how you look at it. And there's 8 billion people in the world. It's somehow we managed to waste about 40% of it. So a significant number of people, have food poverty and starvation. So how is that possible when we've got a system that in aggregate produces more than enough? So to me, that is a manufacturing problem. There's issues around the growing, and the transportation and the storage. But looping back to this idea of consumption, it's interesting if you look at low to middle income countries, there's a lot of food wastage, but it tends to happen at the growing and transporting and distribution and storage level. Once it gets to the home, relatively little is wasted. Look at richer economies, we do this bizarre thing. We buy more food than we need, we keep it for a while in the fridge, and then we chuck it away. So this is what I mean about the consumer being part of us. The consumer, that's a terrible way to look at it. You and me, you may be excellent at this, I'm terrible at this. But I feel that we as consumers should be much more aware of our role in something like food security.
Since you mentioned food, one of the examples you take quite early in the book to show how complex manufacturing systems are is the lettuce. And
yes.
You'd imagine that manufacturing, growing, distributing lettuces would be quite straightforward, but why is it complex?
I love this story. So writing this book was a great, it's going to sound so pretentious, again, a journey of learning for me. It was great. So I just thought, right, I think I know a bit about supply chains, given my job, but I went to colleagues who were real experts in each of the things we cover in the book and said, and in this case, it was a wonderful colleague called Mukesh Kumar. And I said, Mukesh, can you just give me an example of a supply chain that's something that's superficially simple, but is actually quite complicated? And I thought he was going to say, I don't know, a paperclip or a bicycle or something. And he said, lettuce. And I went, I think I may have misheard you or asked the wrong question. And he said, no, look at this. And it is complicated and complex because I thought you literally put some seed in the ground, it grows, someone comes along, chops it, off you go into a truck, eaten. But even something as simple as a lettuce will have at least 3, possibly 4 stages in it. There is the process of growing it, everything entailed there, and all the fertilizer and equipment and people that are needed to be deployed to grow it. Then there's the harvesting of it. Then there's the washing and preparing of it. Then it'll go somewhere to be chilled and kept for a very short while. Then it'll go off on multiple different journeys, depending whether it's going to be ending up on a supermarket shelf, whether it's going to end up in a restaurant, whether it's going to go somewhere where it's going to be further processed to make it into a, pasta salad or something. Each of those things is happening. And it's not like one farm delivers all of it. There's multiple farms. There's also the issue of we want lettuce all year round. So it's a multinational, it's a global supply chain with particular emphasis on things coming perhaps from Spain, which is constantly being adjusted. So we want to grow more lettuce in this country, which is very sensible, local. But then if we have a rubbish spring and a rubbish summer, it's not going to be, there aren't going to be enough grown. But then demand will drop down again. But then if demand does suddenly shoot up and we have a hot summer, that's maybe not so good for lettuce. So you need to get it from elsewhere. Suddenly you've got this incredibly complex set of levers you're trying to pull. And then you realize how smart the people are who work in this world. It's an optimization problem, even for something as simple as a lettuce.
The need to deal with this complexity and our desire to be as efficient as possible has led to potential vulnerability. And you make the point that the desire to do a good thing, that is reduce waste, has led to fragility in the system. Why is that?
Well, if you take the purest view of what various versions of lean manufacturing are, at their heart, they have one simple principle: eliminate all waste. Anything that is not adding value to what the customer gets should not be there. So waste can mean anything. It can mean, are you cutting something and there's too much, offcuts there. It could be you're using too much energy. You're making too many of them. But there's also this issue of you want to eliminate. So in some ways, if you do it really, really well, you eliminate all waste. You don't have redundancy. You say, well, why do we need to have 2 of these machines if one can do it really well? That's very sensible. But what happens if that machine breaks down? And you can then extrapolate that to saying, right, we're going to have one source of supplier for something, and it's going to be very, very far away. And you can go, well, that's brilliant. They may be the best company in the world to make that because shipping costs are so ludicrously low. I mean, per ton, even with the spikes in demand, it's still very low. You can have your supply chain, covering thousands of miles, tens of thousands, hundreds of thousands of miles in terms of all the things moving backwards and forwards. But then when something goes wrong, you're completely stuffed. And the clearest illustration of this is the Suez Canal. Also Panama Canal, of course, but the example I'm going to give is from the Suez Canal.
Where the ship got stuck.
Right. Yeah. And so a 200,000 ton ship, I didn't realize this, but the Suez Canal is so narrow, they have one-way traffic. It was, it was meant for both directions, but no, they have to literally stop all the ships at one end, have them all going one way. And when they've had enough going through, then they can say, well, send the other lot the other way. And if you just look at, it's worth it, just going on YouTube or Instagram and just looking through a few pictures taken from the bridge of a container ship with, 20,000 containers on it, there's not much room either side. And so the fact that, whatever it is, a third of the manufactured goods in the UK, something like that, will be coming from China or I think that's a figure we can work with. It's not quite right.
Yeah.
Coming there, and a huge amount of it will be going through the Suez Canal. Roughly 10% of all global trade in shipped goods goes through the Suez Canal. And one person on one ship, by just nudging the tiller on a little switch, slightly one direction, going a little bit faster, bang, 6 days, I think it was, no trade could flow. No goods could flow. And you go, that doesn't sound very resilient to me. It's been optimized for efficiency. It was not optimized for resilience.
Throughout the book, you look at various different factories at different scales, from individual, which is, craft-based, to mass manufacture via batch manufacturing. Do all those three things have stuff in common?
They do. You can break any factory, and I'm using the term factory in its broadest sense, because some people say, no, it's only the mass manufacturing thing is really a factory. The rest are different things. But I think it's simply just to say, no, a factory is a place where stuff is made. And if they're just making one or making 1 million, it's still a factory for the purposes for the book. They all basically do the same thing. You've got some kind of inputs, and that could be people, raw materials, components, whatever. And you've got outputs, something coming out the other end of the factory, which is of higher value than all the stuff that came in. And in the middle there, you've got people, you've got materials, you've got machines, and you've got some sort of methods being followed. Every factory, whether it's one person bashing a piece of metal with a hammer, through to massive car plant producing 1 million cars a year, they're doing the same thing. That core bit doesn't change.
And you talk about manufacturing being a series of trade-offs. What are those trade-offs? So
it's this different ways you can look at it, but 3 particular trade-offs can be cost, quality, and speed. So if I say, right, this mug, I need a new one of these, and I want it tomorrow, and so assuming someone has to make that, they can go, wow, okay, we can make you a mug by tomorrow, but that's going to require us to get some extra people in, pay a lot of overtime, get it to you. If you want it at that quality, if you're willing to accept it quick and I can just bodge it together myself, then yes, your quality will go down. So you're always trading those 3. One example is trading those 3 off. The speed you get it, the quality it is, and the money you pay for it. And every manufacturing process will end up trading off at least those 3, if not many other things as well.
And you trace a history of manufacturing from the first industrial revolution to where we are now, which potentially, and we'll get into this, is the 4th industrial revolution, if you like. So I was left wondering how important war has been to our manufacturing progress. You talk about the example of, my French accent is appalling, but Honor Blanc, who was a gunsmith, making a gun more efficient as a kind of key moment in the Industrial Revolution. War, does it produce progress?
It does. And, of course, we'd rather not be in a state of conflict, but there is something extraordinary that happens in wartime. Things accelerate faster because there's an absolute compelling need. It doesn't have to be a war. There just needs to be a crisis situation where something very bad needs dealing with, and all the normal, all bets are off. You just need to solve that problem. It's similar to the situation with the COVID pandemic, where it was such an existential crisis, things could change and move much faster. The example, touch on it briefly in the book, of vaccine production.
Yes.
A thing that should take 10 to 15 years happens in about a year.
Well, that's really intriguing. And obviously, it's something that set millions of conspiracies off across the internet. So, yes, how did they reduce the time it took to create a vaccine?
So just to be absolutely clear, there was no compromising of patient safety. The risks that were taken were financial. So normally, in a very rational world, you'd say, here's a thing we think might cure something. We're going to do some research and see if the science works. Does it actually seem to treat that? And of course, you need to make sure that it is safe. And you need to make sure that it does something useful for real patients. And then you have to have the ability to scale it up and do lots of trials to make sure it's working on bigger and bigger groups. Normally, those all happen in series. And you do one, a bit of research. So a scientist might go, I think it might be this. And they trawl off and they try and raise some money to do that research, which can take, 3-5 years. And then that has to be assessed and reviewed. And then they go, oh, yes, but maybe you need to do some more research. And then they do that. And then they go, okay, we're going to start a clinical trial. Okay, we're going to do that. At each stage, it has to happen in series. You have to wait for the result of one before you commit any money to do the next one. What happened during COVID was that they said, if we assume it does work, can we jump to the next stage? Can we say, well, if we assume it's going to work, we're going to need to produce hundreds of millions of doses. So why don't we start preparing the manufacturing before we know we're actually going to make that particular version? You get everything ready, but then, of course, the problem is it doesn't work. In normal times, you'll say we've ramped production up for this drug, which we're now not going to release because we found it doesn't work. You would never do that. You'd wait for the results and then you'd scale it up. COVID they kind of shoved it together and said, and overlapped it. I'm not sure these hand gestures are going to work for everyone on the podcast.
On the audio, but that's fine. We'll clip it up on YouTube, everyone.
I'm not sure my hand gestures make much of a contribution there. Does that make sense? The risk was with the finance. It said we're gambling with money to say, we'll take the bet. We'll say, we'll assume it works. Now, what do we need to do as the next stage? And we'll start doing that.
In other words, the trade-offs that you talk about every manufacturer going through, they're thrown away, essentially.
The money one, yes.
The money one.
Yeah, and then that loops back to, I've neatly steered us away from actually answering the question you asked me, which was the wartime accelerating things. But I think it's war as an example of a crisis. It's crises that lead to advancements. And war is just a particularly unpleasant one we deal with and unfortunately are dealing with on an increasing basis now. So yes, I think if you look at the progress of technology during, the First World War and the Second World War, it was extraordinary what was achieved then. Of course, we'd rather not have had that happen on any measure. But if you just objectively look at the technology and the things we had before the First World War and then after the First World War and before the Second World War and after the Second World War, extraordinary progress took place over 4 and then 6 years. So yes, war does drive progress.
And what are we learning from Ukraine? That we need energy security, presumably?
Yeah, slightly above my pay grade, but yes, absolutely energy security is a thing, but also not really my area, but you see a changing nature of the technologies used to fight in wars. So I'm not particularly comfortable talking about this, but this is just things that anybody could have observed. The idea of building exquisitely complex systems for delivering something somewhere and then getting that exquisitely expensive system to come back again with the pilot still on board has been the way we do things. And, look at the technology around aircraft and it's just phenomenal. We're moving now to a model where you say, well, why does a person need to do that? Well, one of the arguments is because the person has to make a decision of what's happening. And you keep accelerating that forward and you go, well, then we have drones and you can do it remotely. And then you say, but these massive remote controlled missiles are one thing, but then you just see this extraordinary world of the very, very low cost drones, the ones you can buy from your local electronics store, being used at scale to just change the nature of how combat happens. And that's again, I'm not making any judgment on anything here. It's just from a technological perspective, we see an extraordinary change. And that is only happening because of massive resource constraints. When you haven't got a lot of one thing, you need to find another way to solve that problem. And we're seeing examples of that now. Things happening very quickly, iteration happening very quickly. Try a thing, does it work? Doesn't it work? Well, try another one. Very, 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 very fast, which is not typical of how innovation happens in big, complex systems.
I hope you're enjoying the show. Bit of news from the Material Matters stable. Our London Fair returns to the London Design Festival 2025 from the 17th to the 20th of September. And what's more, it has a sparkling new home. We're taking a floor of Space House, one of the city's most distinctive modernist buildings. Originally designed by Seifert and Partners in the 1960s and once home to the Civil Aviation Authority, Space House is Grade 2 listed and has recently undergone a restoration and modernisation programme led by architect Squire & Partners and developer Seaforth. So it's all very exciting. However, it's also important to point out that while our building might have changed, the ethos of the fair remains the same. We want to showcase the importance of material intelligence in architecture and design and illustrate how using the stuff that surrounds us more wisely could make the world a slightly better place. If you're interested in taking part, drop us a line at hello@materialmatters.design. That's hello@materialmatters.design. Before that, of course, we're launching Material Matters Copenhagen. which runs from the 18th to the 20th of June at Christianshavn and is part of the 3 Days of Design Festival. We'll have the likes of Hydro, AHEC Europe, The New Raw, Abalon, iFungi, and Patch Studio taking part, to name just a few. It's going to be great, and I hope to see you there. The obvious question to ask of all this is, how did we get into a situation where raw materials are sourced in one part of the world, sent to another to be processed before being sold to another, and then sometimes returned in the form of waste to the countries that possess the raw materials in the first instance? I mean, it's nuts, isn't it? If one took a step back and looked at the situation we were in and how we got there.
Yes. I mean, we can bring an economist into the conversation who could talk much more eloquently than me about that. And there is this comparative advantage thing. You know, you say, well, hang on, what have we got? What has someone else got? And we're going to trade the things, and that may require us to bring something in, do something to it, and then send it back again. But at one level, can be seen as completely mad. You know, why would you do this? And but economics causes some very distorting behaviors. One of the examples we looked at in the book was the processing of fish. So I certainly at one time, it was more economically viable to have fish caught in Scotland, frozen, shipped to China to be processed, to be shipped back, to be sold again in Scotland. And you go, how is that a thing? But economically, if you take a very narrow view on it and literally looking at the balance sheet and going, that is a cheaper way of doing it. But again, the little bit of economics I can remember from my A-levels was this idea of externalities. That, you know, a thing that happens that is not, you don't have to deal with. So yes, that makes you money and you save costs, but the pollution, the energy required to do that journey, the pollution created by the ships going all the way there and coming all the way back, that's the pollution bit is not your problem. You know, it's someone else's problem. You've got a cheaper fish. You've acquired a cheaper fish processing technology. Your manufacturing system economically works fine. But when you include those externalities, it doesn't make any sense at all. Well,
I mean, you do get into economics just fractionally towards the back end of the book. You're not a huge fan of GDP as a measurement tool.
No. No, well, I'm definitely not alone on this. And my colleague, Diane Coyle from the Bennett Institute, has a book coming out very soon on this topic. And I strongly recommend reading that because it makes this point. It's literally, if we just measure success on how much money have we spent buying stuff, that ignores completely any damage you might be doing to your natural environment. You just go, well, it doesn't matter. It doesn't count. Because the example that I was given years ago was of the Exxon Valdez oil tanker that crashed off the coast of Alaska, one of the worst oil spills ever. In GDP terms, after the event, they looked back on it and said, well, actually, it was a positive event because it created...
Because they made money, lots of jobs, mopping it up.
Right. And all the hotels and the restaurants did a great business around it. So that's a lovely example where it doesn't make sense. Logging, destroying bits of the Amazon forest, you go, yes, that is bad for the natural environment. Everybody will agree that is destroying a thing that's irreplaceable or functionally irreplaceable. But it's actually good for GDP because it's created lots of jobs in the logging industry and the timber industry. So yes, I'm not a fan. You need to have some measure of progress and some measure of performance.
Yes. How do you measure it in that case?
Well, you can include those things in your measure of economic performance. So rather than just saying about the natural environment, well, that's just not a thing for us, you actually put a value on it and say, well, if we're taking stuff away, if we're destroying these things, that should be a cost. And if we're planting things, well, that's an investment. You can start to include consideration of the natural environment in a measure of a nation's performance, but also the skills of the workforce, the education. Have we done a thing that has led to people improving their opportunities in life? All these other things you can include. It's just getting to an agreed set of metrics. And the reason we use GDP is because it's good enough.
Yes.
And then, of course, you measure what you can measure. The numbers are there. You can look at them and you start arguing about, remember the time we went through an era of we're going to measure national happiness.
Yeah, that was at the beginning of the Cameron years, I seem to recall.
Right.
About 2010. Yes. Yeah.
Yes.
Steve Hilton was very influential at the time.
That's it. And I mean, I like the idea of it, but how do you operationalize it? How do you make that into something that can actually be used to drive the thinking of UK Treasury or the whichever government department may be saying, we need to focus on this.
So like tariffs, GDP, fundamentally, what you're saying, it's a blunt tool.
Yes, but a blunt tool can still be effective.
Yeah, fair enough. I mean, up to a point, Your Life is Manufactured is all about technical innovation, from the invention of the Jacquard loom through to the rise of AI, and its accompanying disruption. But innovation comes in many different forms. And you take shipping containers as an example. How did they affect manufacturing processes?
It is an extraordinary thing. And my poor family are utterly sick of me talking about this and pointing out different shipping containers as we go down the M11 or wherever. But it's just mind-numbing. There's a great book somewhere. I've got it here. If I'm going to reach up here, by Levinson, called The Box. And I'd really strongly recommend people reading it. It's very, it's the whole history of the shipping container. Quite a thick book too, but it's a great read. It's just something that's so simple. Up until that point, until the invention and development and deployment of the shipping container, if you wanted to move stuff, you would take it to the quayside and it would be manually loaded onto a ship by very skilled dock workers who would load the ship so it was always balanced. There's a huge amount of skill in loading a ship safely. But it was expensive because you needed lots of people to do this. And there's a scale problems and there was breakage issues and all sorts of things. So the basic idea of saying, well, just to simplify things, why don't we put everything in a box and move the box onto the ship? And then hang on a minute, if we actually make all the boxes the same size and we get the rail industry and the truck industry to agree this, then if the boxes are all the same size, we then have what's called an intermodal transport system. And wow, suddenly everything flows. Problem with it is it caused mass unemployment.
Yes.
It destroyed
cities, fundamentally.
It really did.
Yeah.
Absolutely. And the situation around Liverpool and London are classic examples of destruction of an entire community because of an innovation. And we always make this point with our students, there are always unintended consequences of any innovation. And that's a great example of it, a tragic example of it. But what it meant was that the cost of transportation per ton dropped by something like over 90%. So suddenly, in the past, you'd say, well, we have to manufacture close to the market, or we have to be near a source of raw materials because the cost of shipping it a long distance is so high, we'll have to charge the customer so much, they won't buy it. Now, suddenly, you go, well, if the cost of shipping has dropped by 90%, actually, it makes sense. It's absolutely fine to make things here and sell them over there. Again, I'm pointing, sorry about this, to make these.
That's fine.
I need more practice of this audio stuff. You can operate your manufacturing system over greater distances when the cost of transporting things is very, very low. And the shipping container, that's its main thing. It reduced the cost of shipping dramatically. I mean,
is manufacturing still, and we did touch on this earlier, but I'm quite keen just to have another little nibble at it. Is manufacturing still important to national identity? I mean, there was a point in this country where some politicians and organisations, I think the Design Council, for example, were describing a model where the UK was, quote unquote, a creative island. We would come up with ideas and designs and other places would make them. I'm presuming you didn't have much truck with that.
I can see up to a point it does make sense. But I think it's with all of these things. If you go to the extreme and you go to the 100% version of it, then it breaks down. So to me, I'm not a lobbyist, demanding that we, make everything locally and we go back to some sort of pre-industrial revolution, rose-tinted view of the world, which is definitely not a good time to be alive. Back then, I think average life expectancy about 35 or something. It was
we definitely live longer now. Yeah.
That no one can argue with. Yeah, we'll go with more of that, thanks. But there is something about the ability to make things domestically does lead to economies that are more resilient, that are more sustainable and more equitable. And that last one of equitability, of opportunity, equity of opportunity, manufacturing provides good jobs. Not all manufacturing jobs are good. I'll make that point very clear. I hope that comes out reasonably clearly in the book. There's some really bad things in the world of manufacturing, particularly for opportunity. But there's also some fantastic opportunities. But I guess the message I'd dig around there goes back to the world where I work. I work in a university. And so one of the things that the UK is very strong at is science and technology. And for a relatively small country, we do punch above our weight. in terms of the citations and the output of research per capita is very high. I mean, sheer volume terms, sure, the US and China can beat us, but per capita, we do remarkably well in the number of Nobel laureates and all these things. We're still good at that. We've got to be very careful we don't get arrogant and complacent, but that bit works. Now, but for that stuff to make lives better requires us to be able to convert those things into real products, things that people want to buy to improve health outcomes, to improve speed of transportation and communication, nutrition, whatever it may be. Science and technology doesn't do anything on its own. It has to be embodied in a product of some sort. To do that, you have to have the ability to make things. And I think the mistake was saying, it's okay, we'll do this bit of research and development, and there's a production bit, and we'll unplug that and we'll shove it far away somewhere else because it doesn't matter. It's the low value adding bit. The bit that was missed in that, and it does make sense in some ways, in many cases, but it's the boundaries between designing, working out some science and some technology, working out how to design a thing that might be based on that. And to do that, you need to understand how it's going to be made.
Well, presumably there must be benefits to having an ability to manufacture near somewhere where people are designing and creating things. There must be.
Totally. And lots of evidence to show this, because you iterate between. You go, well, I've got this thing and now we're going to make it. And actually, well, if we make it like this, then it could add this other functionality here. And so you go backwards and forwards between those who are doing research, development, and scaling up of production. You have something really good going there. But if you've got those people very, very far away, you lose that ability to iterate to a better solution. The other thing is about where value is captured. And so the ability to make things means allows you the opportunity to capture more of that value for yourself. And so one of the ways the debate gets very, again, back to bluntness of messaging, is sometimes manufacturing is, we're making a thing that already exists and it's not going to change. But the truth is, manufacturing is all about change. Nothing stays the same. There is a constant process of improvement. And I have this, it's not with me here, it's back at the office, but my rather sad collection of old mobile phones. And I've got, this Motorola one, which is the size of, a batch loaf of bread, weighs several kilograms, at the size of a car battery. And that was an incredible technological achievement. The science and technology to make a mobile phone that you could just about carry around as long as you didn't mind, straining your shoulder, was a phenomenal achievement. Cellular phone technology is just amazing. It could have just stopped at that point and said, yeah, you go, we've made it. Let's just make loads of these and see if anybody buys them. Instead of which, we've gone from car battery size, ludicrously expensive telephone down to a multifunctional electronic device that sits in our pocket with the power of a supercomputer of 30 years ago. That's been a process of not just science and technology getting better. It's been the process of understanding how do you manufacture all of those technologies to allow them to be ever more miniaturized and to add ever more functionality to them. These things work together. Design and production iterate between each other.
There's something that is made in this country that I was really intrigued by and was a little surprised. I'd never really thought about it, that you write about, which is the switch on a kettle.
Yes.
So I hadn't really considered it, which is odd because that's kind of my job to consider stuff like that quite often. How does it know when to turn itself off, a switch on a kettle?
It's a beautiful example of a nice GCSE level bit of physics or material science. It's bimetallic. So there's two dissimilar metals are put together. One of them expands more than the other when it's heated up. And so remember back doing that experiment over a Bunsen burner or something where it just sort of slowly bend and you go, there you go, that's bimetallic action there. But a very smart guy called Dr. John C. Taylor, I should declare an interest here. He's the guy who endowed the position that I have.
I was going to say, that name has come up before. Yeah.
There we go. So he's a wonderful guy, lives on the Isle of Man, and he took that idea and the work that his father had been doing on a whole series of thermostatic controls for all sorts of things like heated suits for pilots when we didn't have pressurized cockpits. Lots and lots of clever ways of using bimetallic technology to switch things off or on. And John C. Taylor developed this beautifully elegant little bimetallic blade because he looked at the world. This is a nice example of materials, a new material emerging, changing the nature of the product. So kettles used to be metal, yeah?
It's them turning plastic that changes technology, which I thought was really intriguing.
Yeah. And so this idea, you could say, well, why do we need to suddenly change the technology? Because the materials changed. Because if a metal kettle boils dry, if you switch it on and wander off, like, me first thing in the morning, I can barely work out how the tap kettle thing works anyway. But you switch it on, if it's a metal kettle and it had no switch on it, it would just keep boiling, boiling and boiling. And then the element would just fry itself and it would just go bang and switch off. If it's a plastic kettle, much worse things would happen. It would boil dry, the plastic would melt, land on the element and most likely catch fire. So kettle manufacturers saw the potential of plastic and said, wow, we can have much more creative designs.
Because it's what? Because it's lighter, it's more moldable, lower cost production.
Exactly. Presumably. All of those things. You can just produce more variety of products. They stop looking like those stainless steel standard things. But none of them would do it because they said, well, the risk is too great. So John Taylor, by saying, I can solve that problem for you. He didn't say, oh, here you go, here's a piece of bimetallic. Do you want to buy it? He saw that problem and said, I can deliver a complete kettle control system for you. I will manufacture it. You just need to plug it into your kettle. And he did that, if I remember my story correctly. He got a kettle mocked up. He went to a design consultant. He said, make a plastic kettle and my thing in it. And we can go to then the kettle manufacturers and say, you can make kettles that look like this now, and they're guaranteed safe because this switch works every single time. It's not electronic. It's nothing particularly complicated. Sorry. Yeah. In that case, complicated is the right word. It doesn't need any electronics. It is literally material science and physics working. It just goes click. And that force, the way the little bimetallic blade is shaped, the way it's treated and designed means you get a huge relative movement for a tiny change in temperature at a very precise point. And it works every single time. And the amount of energy that's saved by, back in the day, the kettle, you want to make sure that water's really boiled. So you'd leave it rumbling away for a while longer and then go, yeah, it's definitely boiled now. Those 2 or 3 extra seconds, if you add them all up, comes to some phenomenal number of wasted energy. It's a lovely example of a new material arrives, requires some other piece of technology to make it useful, the bimetallic switch, which then has a secondary effect of actually making that product more efficient.
And we're talking materials now, Tim. Which is ostensibly what this podcast is all about. So can we talk about the role of silicon and what part that's played in modern manufacturing?
Oh, what a lovely segue into, yeah.
I do this for a living,
The only thing we need to get back to is I'm going to try and make a connection between silicon and cake at some point. That's my ambition for the next few minutes.
Okay.
Bear with me. So yeah, the development, I guess it goes back a wee bit further than to understand the power of silicon. Is going back to, as you were saying earlier on, there's a lot of stuff happening in France in the 1700s and 1800s. And yes, there was the interchangeable parts of Honoré Blanc and all of that good stuff there that made the weapons manufacturable. But there was also the arrival of digitalization of manufacturing in the early 1800s. This is Jacquard and his...
And the loom.
And the loom,
yeah.
Exactly. And so that is one of the earliest successful examples of digital technologies being applied to a manufacturing process in a rather brutal way to de-skill it, which is, as with these technologies, there's always a consequence of this. By making looms that could make a standard thing without someone having to change all the settings every time was a big step forward. So that digitalization allowed automatic control of a loom. Fast forward and you go through the whole arrival of the assembly line with Henry Ford and all of those good things, and the disassembly line of an abattoir being used as a model for an assembly line. I quite like that analogy there. And then it came all the way through, and then there's about controlling your manufacturing process. You're producing thousands of things. You've got to be able to control what's going on there. And the lovely story I like is at the end of the Second World War, one of our UK's most successful companies was Lyons & Co. That used to make cakes and have the Lyons Corner House. I'm not old enough quite to remember that, but I've heard of them. And I remember the Lyons brand of cake, certainly. At the end of the Second World War, they were looking at their manufacturing operations, and they had a massive national network of all these little restaurants and cafes and bakeries. They needed better data on what was going on to manage this making, moving, and consuming, the standard journey of a manufactured product. And they said, rather bizarrely, they said, well, we need a computer. And so they went, funnily enough, to America. They sent some of their senior managers off to the United States to see whether some of those computers that have been developed for defense purposes could actually be made into commercial products. And bizarre conversation happened where they arrived in the US and they said, yeah, but there's people in Britain doing that. In fact, in Cambridge. So they went, oh, blimey, flew all the way back, bumped into a wonderful guy called Maurice Wilkes and his team who'd built a computer called EDSAC. I forget what it exactly stands for, but it was one of the first electronic computers, but it was massive with all these valves, and every day they'd switch it on, a whole lot of these valves would blow up, and it was incredibly impressive, but not very reliable. But the Lions bakery company said, can we have one of these to manage our bakery? And Maurice Wilkes apparently went, sure, why not? And so they built a computer for Lions.
Which is extraordinarily far-sighted.
It absolutely was. It's just bizarre how they did. But I guess big privately owned companies, I think they're privately owned, could make decisions like that and say, I believe this thing, we're going to do it. There is the story of the comparison of, so I'll finish that bit and I'll come back if I may in a second. Stop me at any point. This could go on for a while. I'll be brief. They started making those, and then they realized they created Leo, the Lions Electronic Office. It was a giant computer that controlled the operations of Lions, its massive empire around the United Kingdom. And they thought, well, actually, maybe other people want to buy this. So they went to the government saying, we are at the vanguard of computing for industry. Would you like to back us so that Britain can be at the forefront of the computing revolution? And apparently the minister went, I'm sorry, I'm confused. You make cakes. And now, it can be rather cruelly contrasted to the situation in the US with the early days of IBM, which had been all punch cards and census data capturing and the Hollerith machine and all that stuff. They received massive amounts of money from the US government, who said, oh, we can see that you could really take this forward. This has huge potential. And so there's often a contrast between the role of the government, either just going, but you make cake, or this is really good, we should back you so that this nation can be a leader in this field. But, we can discuss that for quite a long time.
I am quite interested in that. I'm wondering whether we should stick to silicon for the moment, because
all right.
The role of government is kind of interesting, but let's keep going with silicon.
Yeah, thank you for keeping me to task. This is good. So then you've got valve-based computers, and they then took off, and loads of companies started making them. But they were still huge. Literally, each valve, each electronic switch was the size of a light bulb, and you needed thousands of them, and they kept blowing up because they get too hot. And then a group of researchers in the US got the Nobel Prize for developing the transistor. So it was taking the idea of an electronic switch and making it tiny with semiconductor material. But they were still, a couple of centimeters high each one. And, they were still way smaller than a light bulb, but still pretty big. And then we started building computers based on transistor technology with these rather large transistors. So you have the sort of still the size of like a cabinet fridge or two. It was still pretty big. And then the really smart thing happened, bringing it finally to silicon, which was they said, can't we use layers, can't we etch onto silicon the function of a transistor? So you build up layers and you etch bits away, and you can actually make transistors by stacking up layers of material. And you can do this in a tiny, tiny scale. They came up with the idea of the integrated circuit. You put circuits, you made a planar transistor, flat transistor, and then you've got loads of these together, and you could make lots and lots of transistors on a tiny bit of silicon. And then they got really carried away. I said, well, can't we make the other components of a computer? Just as could we actually make a micro processor, a little tiny computer etched onto a piece of silicon? And they did this. And then rather wonderfully, they went, we've made a tiny computer. Who's going to want that? Allegedly, because it was just not obvious. Just making it tiny, why does that make it better?
Yeah.
And then, of course,
the PC thing happened. Yeah.
Exactly. But it took all of the geniuses of Bill Gates and Steve Wozniak and Steve Jobs and all of those people piling in going, oh, no. This transforms the market for computing.
But I always love that story about people who invent things and then don't know what to do with them. I mean, the car, Benz, he created the first car and it sat outside his house for ages because he didn't want to drive it. And it was his wife that took it out for the very first time. So effectively, without telling him, the first ever car was joy-ridden, which I always kind of enjoy that story.
That's brilliant.
I mean, that might be, somebody might come in and tell me that I'm wrong, but I'm pretty certain that story is true. So we've got to silicon.
Sorry, that took a little while. We got there.
No, that's all good. That's all good. So we have digitization, and we now create vast amounts of data. And you make the point that some companies create too much data. Can you have too much data?
Yeah. What a great question. Having a lot of data is a problem, because what do you do with it? And it's fundamentally business and manufacturing is about, going back to trade-offs, it's about making decisions. Are we going to do this thing or not? And just having lots and lots and lots of data that you can't necessarily process isn't helpful, because you become swamped by it. So what we're seeing, I think, is so exciting is in this we're in the middle of AI-related innovations, is that it becomes a super tool for helping humans make better decisions. By dealing with this vast complexity and vast scale of data, the tricky bit is not so much that there's a lot of data out there, is the variety of data, the quality of the data that you've got now. And this becomes a big issue. Data quality. Where has that come from? And what does it mean? And maybe just leading it, if I may, because we could drift into the highfalutin world of AI, and
we could spend a lot of time on AI. Yeah.
But if it's okay, if I bring it back to a manufacturing process.
Absolutely.
So the availability of AI to support decision-making, if we just keep it framed like that. So manufacturing processes, some of them have not changed for a very long time. Things like what we call the foundation industries, so glass, steel, paper, cement, things like that. We know how to make these things. We've known for quite a long time, and they've been constantly optimized and improved and improved and improved. But we still need to improve them because they tend to be very energy-hungry industries. And so you end up with very, very skilled people who've worked in that industry for a huge amount of time, who know how to optimize things. And they're absolutely brilliant. They're worth their weight in gold. But they're retiring. The ones who've grown up through the analog era, where you did everything yourself and you had loads of people looking at processes to tweak and adjust. Those skills are going to be lost at some point. So the ability to attach lots of sensors to these processes and use the data from those sensors intelligently, to use both human intelligence and artificial intelligence to interpret what that means and make quicker, better decisions, is really, really powerful. And we see that happening across many, many sectors. The issue is you've got two different groups of people, both highly skilled. You've got those who understand the processes themselves of what is happening to this glass, to this paper, to this cement. And you have those who understand what AI can do. And what you need is a sort of a Venn diagram of the people who sit at the overlap of those two areas there. And this is something we find fascinating. If you just live in the world of AI and just deploy it to any problem, you'll miss the richness of, but where's that data come from? What's it actually like on the shop floor? What is that sensor actually recording? So what we've become almost obsessed about at our institute is, how do we get a generation of new engineers coming through who get the fundamental understanding about how do you manipulate material at scale, all these manufacturing processes, but who also understand the digital world and the world of AI. And they have both those sets of skills.
Interesting. Really interesting. We are beginning to run out of time. So I've got loads of questions, one of which was going to be the government's role in manufacturing. But I think I'm quite keen, before we finish, to talk about the importance of sustainability, which you leave till the end of the book. And yet you point out it's going to be a key driver going forward. So I'm interested, why did you leave it till the last chapter or so?
It's a great question. There's multiple answers to that. The one I think is simplest is, it is, in order to understand how we need to build a more sustainable manufacturing system, we have to first understand the manufacturing system. And I think, be slightly careful how I word this, sometimes just leaping ahead and saying all these things are terrible, we must stop them, doesn't really lead to constructive change, because it maybe isn't based on an understanding of how things are happening now. And I realize that can sound a bit pretentious, but I just felt that had to be
sense.
Right, build the foundations of understanding, then you can see the damage it's doing, but then you can also see the ways in which it can be improved.
Okay. So then the corollary to that is, can manufacturing industries save the planet?
I think, yes. It's a simple answer.
Good. Let's move on.
Any further questions? By which I mean, we still need to be fed, to be sheltered, to be moved around, to be housed, all those things, to be secure, all of those things are necessary. To do that, we have to manufacture things. So there's two angles to it. One, we have to be better at how we manufacture the things we need now and want now. So it's about being more efficient. It's about being cleaner. It's about just wasting less and doing it better. The second part is if we want things like renewable energy systems rolled out at scale to manage the energy transition, there are a huge number of things that need to be manufactured. You can't just have lots of clever ideas for how we're going to transform the planet. You've got to have the ability to also make those things. So to me, manufacturing, without sounding, over the top, it is the answer, because it can't not be the answer. We've got to make the things we make now better and cleaner, and we're making new things as well. And those things are going to ensure we can survive.
I spotted something in your footnotes that I've been wanting to talk about on this podcast for a while. You used the term green hushing.
Oh.
What is green hushing?
I was really disappointed to learn this. I can understand it, but it's really disappointing. So we've gone through a series of stages where perhaps manufacturing said, well, yeah, we don't really need to worry too much about sustainability because it's not really our problem. People want these things, we make them, it's not our problem. There's been a phase, an era of that changing dramatically and saying, no, absolutely, all manufacturers recognize the impact they have on the planet and want to do it better. The next phase is saying, well, how do we do it? How do we actually make things in a less harmful way? And then there is the actually doing it. And we got all excited when we moved through those three phases and companies were doing it. We went, isn't that brilliant? I give an example in the book of British Sugar and what they did up in Norfolk, which is an interesting example.
Yeah, why don't we spend a bit of time talking about that? Because it is a really interesting example. So it's in East Anglia, this sugar beet factory.
It is, yeah. Well, maybe if we do that and then we can jump back to the issue of green hushing. So sugar beet, I had to learn about this, dug out the ground, delivered to a sugar processing plant, typically somewhere in, many of them are in East Anglia. You wash a sugar beet, you get topsoil comes off it, stones come off it, you then put it into a giant, massive machine which does all this chemical and mechanical processing and all sorts of clever things. And out the other end comes tons of sugar. Great. Along the way, all those rocks and mud were just chucked away. And someone said, well, what if we don't chuck them away? What if we make this factory where every single thing that comes in, when it leaves, it has a value associated with it? They started selling the topsoil. They started selling the rocks. All the energy that they were producing, well, I'll come back to that. At the other end, you make the sugar, but you end up with lots of low-grade sugary-like things that you can't really sell. And someone said, well, what if we built a bioethanol plant at the end? We can then create fuel so that, when you fill your car with petrol and it says E5 and E10, the E bit, bioethanol, and some of that has come from sugar beet. The energy one was interesting because they massively energy-intensive process to go from a beet to pure white sugar. And so you generate lots of CO2 and excess heat. And they said, well, we're just poking out the chimney. Why don't we find a use for that? And then someone said, well, you can use it for ripening certain crops. And so they built or partnered with an organization that built huge glass houses for them right next to their plant. And that was brilliant. And the crop they decided to ripen was tomatoes. So for a while, we had this huge tomato growing facilities, if that's the name, up in East Anglia. And that was brilliant. But then the price didn't work. They couldn't make it quite cheaply enough, and other countries could do it cheaper and better. And then went, we need another crop to grow. And the one they focused in on was medicinal cannabis. And so up in Norfolk is Europe's largest medicinal cannabis facility, because it's a product that requires a lot of energy and the CO2 to speed up the ripening. There's a lovely example of a zero waste approach to a manufacturing plant. Now, the green hushing bit.
Yes, because they obviously are talking about their green.
Exactly.
But lots of companies aren't.
You've nailed it. Yeah, that's it. So they're doing the opposite. They're green shouting and saying, look, we can do this. Please come and learn from us. And they were, Gary, who did it, along with his team, was really keen to say, look, I want people to know about this. There's nothing commercially sensitive. We'll show you. The other thing, though, is the opposite, is green hushing, where you do a good thing and you go, oh, maybe I won't talk about this, because if I start talking about this good thing I've done, people will then point at all the other things we haven't yet done and go, see, you're not doing all the other stuff. So a trivial example would be a hotel that says, look, we encourage all our guests to use their towels more than once. And they go, yeah, but you built your hotel out of concrete and you destroyed a coral reef to do it. So the towel thing doesn't really compensate for the destruction of that. So the safe thing is don't talk about the good stuff you've done because it attracts attention, which is then means people can't learn from what you've done. And that's the hushing bit. It's just, you've done a good thing. It would be brilliant if others could learn from it, but you don't talk about it for fear of the repercussions for the other things you haven't yet done.
Which is, I mean, it's kind of like, I don't know, a woke backlash or some such, isn't it?
It could be framed like that. Yeah. And it's just, yeah, it's a tricky area, and I kind of get it, but if we don't deal with it, it's going to slow things down dramatically.
Yeah. Tim, we're at the end of our time. You've been very patient with me and spoken brilliantly and fluently. Thank you so much.
It's been a joy.
I mean, generally speaking, to end this, the obvious way to end it is to ask you about the future of manufacturing. I mean, where do you see it going? Presumably more local seems to be one of the key takeaways from the book.
Yeah. I mean, there's maybe just end with 2 points about manufacturing. I reckon one, as you say, is local. I'll just stress again, this is not bring it all back attitude. This is having some local domestic manufacturing is a good thing. And if you do it right, it's actually, as my colleague Steve Evans used to talk about this, the idea of the factory that you want at the end of your road, because it's a place that actually generates surplus heat, extra electricity, purifies water. The outputs of the factory are something that sit naturally within a community rather than a thing you want to put somewhere else. So I think that's one future, a more localized approach to it. The second would be personalized. I think with these advanced technologies, with the amount of data we can now gather on consumer behavior and our ability to be much more agile and have perhaps shorter supply chains, you can start to move to a world of personalized manufacturing. And one of the best examples, I'd urge anybody to look this up, is that of personalized medicine. It's a cracking example of where everything comes together. You have the fact that the consumer is part of the manufacturing process. A product is made for a unique individual. And in the extreme cases, the product is made based on the patient's own cells. And the example that's real and happening right now is the CAR T blood cancer treatment. Does exactly that. They extract cells from the body, do a manufacturing process to reprogram them, to be injected back into the body to then attack the cancer cells. And it's extraordinary. And that's almost an icon of what personalized manufacturing can become.
So local and personalized. And it seems to me that you're very optimistic about the future. This is an optimistic book, I think.
It is. And I'm not being all, Pollyanna-ish about it. I mean, I know there's a huge amount of problems, but I genuinely believe that, manufacturing is the answer to a whole bunch of these problems.
Very good. Very good. Well, we have to leave it there. Thank you, Tim, so much for your time. Thoroughly enjoyed that and really, really enjoyed the book. Thank you.
Thank you very much. It's been an absolute pleasure.
Your Life is Manufactured, How We Make Things, Why It Matters, and How We Can Do It Better is published by Faber and is out now. Tim also has a website you can find at timminshall.com. As ever, to find other podcasts I've done and to sign up to our newsletter, go to materialmatters.design. And there are images relating to the interviews on our Instagram page, which is also materialmatters.design. And it would make me incredibly happy if you went to my Patreon page and made a pledge at patreon.com/materialmatters. For as little as £2.50 a month, you can receive an invite to various Material Matters events, as well as getting access to each episode before it's published to the wider world. Material Matters is a completely independent concern, and any help you can offer would be hugely appreciated. Ultimately, you'll be helping to take the message of the importance of materials, skill, craft, and design to a whole new audience. Thanks very much for listening.